Welcome back to the wonderful world of algebra. We are going to finish chapter 6 right now, which is solving systems of inequalities. So we have the Pac-Mans, not just the equal signs. So let's quickly recap from yesterday. I'll give you a problem. 8x plus y is less than 6. If you needed to graph that, what would be the first step? Hopefully you are thinking to isolate the y. So the equation, is y is less than negative 8x plus 6. I would write the x first to keep it similar to mx plus b. That is a 6. So then you're thinking of just this as an equals to make a table of data points that you could plot. So 0 would be a great place to start. 0 giving you 6 because that's your b, your starting amount. 1 would give you 8 less, so negative 2. And 2 would give you even 8 less, so negative 10. You just need a couple points if you know it's linear. So on your axis, you're going to go over 0, up 6, put a dot, over 1, down 2, put a dot, and over 2, down 10. Put a dot. And through these dots, you have a dotted line because there's not an equals to sign. There is not that. So that's why the line is dotted. If there was that equals to sign, the line would be solid. This is supposed to be a straight line. And then it reads less than. So you are shading down. This is the less than side because it goes down for the most part. All right, let's try one more of those just to make sure you've got this. Any ordered pair point in that shaded region is a solution. Your next problem is 3x minus 2y is greater than 10. Go ahead and pause and see if you can get that. All right, hopefully your first step was to subtract 3x. And then you are going to notice that there is a negative in front of the 2. So to isolate a negative 2 in front of the y. So to isolate the y, you need to divide by a negative 2. Now, whenever you multiply or divide by a negative, you need to flip the inequality sign. Because again, in negative world, the opposite happens. Negative 3 is less than negative 2. So anytime you multiply or divide everything by a negative, the inequality flips. Every time you do that. So this would be 3/2 x, and then 10 over negative 2 is minus 5. The 3/2 is positive because it's a negative 3 and a negative 2. Two negatives makes a positive. So to make a table of this, 0 would give you negative 5. When you plug 1 in, as you go up by 2, because this is your run, you're going up by 3 because this is your rise. So as you go up by 2, 2 would give you 3 more, which is negative 2. And then 4 would give you 3 more, which is 1. So you could fill in these middle pieces. This would be negative 3.5 because it's 1.5 more than negative 5. But you really don't need to. It doesn't matter. All right, graphing it. So over 0, down 5, put a dot. Over 1, down 3.5. Over 2, down 2. Over 4, up 1. Dotted line or a solid line? It is a dotted line because there's no equal to under the inequality, and then this time it is less than again, so you are shading to the ground down. All right, so you've got that. All we're adding now is that we're going to graph 2 of them together, and it's really lovely if you can figure out the point that they cross so that you know when we're doing story problems at what point they're equal, and then one situation is better than the other at another point. Okay, so that's a negative. This is y is less than negative 3x plus 2, and y is greater than x minus 1. This is so exciting, and this negative is totally attaching. Y is less than negative. Whew. All right, so they're both set up to make a table and a graph of. So right away, we could start doing that. In this case, 0 would give you 2. And then as you go up by 1, you are going down by 3 because that's your slope. So 1 would give you -1, 2 would give you -4, 3 would give you -7, and so on. In the next one, 0 gives you -1. And then you're going up by 1. You could put a 1 there, it means the same thing. So 1 would give you 0, and 2 would give you 1, and 3 would give you 2. So as you're looking at this, do you think you know where they cross? Let's say you want to find out where they cross. Since they're both essentially equal to y, we do have the inequalities, but you could set them equal to each other and get the exact point that they cross. So if you subtract x, you would have a -4x, and then in the same step you could subtract 2, equaling -3. So these cross exactly at the point 3/4. So do you see how it's right in here that they're going to cross? So you could plug that in and get the exact point, but we're not necessarily asked that right now. So let's go ahead and just plot them both. All right, so the first one is going to be over 0 up 2, over 1 down 1, over 2 down 4, and over 3 down 7. That's going to be a dotted line, and then you are going to shade to the ground because it's less than. The second one in green is over 0 down 1, over 1 up 0, over 2 up 1, and over 3 up 2. And that is going to be dotted because there's no equals to, and this reads is greater than, if you can read that, is greater than. So this is shaded above. So the answer, whoops, right here, is where it's double shading, which is right here. So any ordered pair point in this double shaded region is a solution. Now it is not a solution if it's on the dotted line, because the dotted line is less than or greater than. It does not have an equal to with it. So any and every ordered pair in that blue region is a solution. Awesome. All right, let's do another. So your two equations are x is less than 3 and y is greater than x minus 2. All right, so the first step would be to make a table. For x is less than 3, that means you're thinking of an x equals 3 when you make this table. That means x is always equal to 3 and y can be any number, like 0, 1, 2, 3. So when you're graphing this, any number over 1, 2, 3, and then up or down any single number. Over 3 up 0, over 3 up 1, over 3 up 2, over 3 up 3. This is that vertical line. This has no slope, but it is a line. And then this reads as less than, so you are shading to the smaller less than numbers. Second equation, you are thinking about y equals x minus 2. There's nothing we had to solve to make this table. 0 gives -2, and then the slope is 1. So 1 would give 1 more than -2, which is -1. 2 would give 0. 3 would give 1. 4 would give 2. And I'm going to go up to 5 because that's where they cross. Just kidding. 3 is where they cross. 3 gives 1. So I just went up to 5 for I have no idea why. All right, 0 gives -2. Put a dot. Over 1, whoa, hold on. Here's my axis. 0 gives -2. Rewind that. This is very exciting. So I'm going to make the axis a different color. All right. 0 gives -2. 1 gives -1, 2 gives 0, and 3 gives 1. 4 gives 2, and 5 gives 3. We're looking for x equaling 3. So that is where they cross. This time you are shading, and these are both a dotted line. So let's see. Let's make this dotted. Okay, this is now going to be blue. Very exciting. Okay, dotted line, because there's no equals to sign. If there was an equals to sign like that, it would be solid, but there's not. It's dotted. Okay, so now this other one in black is also dotted because there is no equals to sign. If there was an equals to sign like that, it would be solid, but there's not. And then you are shading greater than, so you're shading above. So the double shaded region, I have every color already used. The double shaded region is, again, not the dotted lines, but everything in here. So every ordered pair in this region is a solution. So do you think over 0 up 5 is a solution? You betcha. It's right around in here. So that's going to satisfy both if you plug it in. I'm going to give you one to try. These can also have all solutions or no solutions, FYI. And again, you can also have to solve them. So we're just sort of starting out easy. Okay. Do you already know what this is just by looking at it maybe? See how the lines are parallel? So it's all going to depend on the shading. The first one, 0 gives 3, and then you're going up by 2. So 1 gives 5 and 2 gives 7. In the second one, 0 gives 0. So 1 gives 2 and 2 gives 4. So let's go ahead and graph both of those. Holy moly, what just happened? Okay, let's go ahead and graph both of those. So over 0 up 3, over 1 up 5, over 2 up 7. Is this a dotted line or a solid line? It is dotted again. This is the inequality we're looking at. And it reads is greater than. So shade up. And then the red one is over 0 up 0, over 1 up 2, over 2 up 4. Okay, this is also dotted. Parallel. They're never going to cross, but these are inequalities, and this is less than, so this is shaded below. So there is no place that this is double shaded. If the inequalities were both opposite, it could be the region in the middle if the green one was below and the red one was above, but they're not that way. So there is no place that there's double shading, so this is no solution. The no ordered pair will satisfy both of these. There's no place that it is double shaded. Let's just try one more. So y is less than 2x plus 4, and 6x plus 2y is greater than or equal to -2. All right, go ahead and try that, and we'll come back in just a minute. Okay, hopefully you have had plenty of time to figure this one out. The first equation starts at 4, and the slope is 2. So 1 would give you 6, and 2 would give you 8, and 3 would give you 10. The second equation does need to be manipulated to put it in y equals. This is in standard form, so you could find your x and y intercept. For some reason, it feels really at home to me to look at y equals mx plus b, so I'm going to move it that way. If you are really feeling one with x and y intercept, you can totally do that as well. No pressure. You've got to do what works for you. We will all get the same answer. We'll just arrive a little bit differently, which is just beautiful. Okay, so -6 over a +2 is a -3x, and -2 over a +2 is a -1. So this equation is -3x minus 1. And if you make a table of that, 0 gives -1, and then you are going down by 3. So 1 would give -4, and 2 would give -7, and 3 would give -10. So let's see if we can figure out where they cross. It looks like they're kind of getting farther and farther away, so probably they cross backwards. We can set these two equal to each other like we did that last time, since they're both equal to y. So the question is, when is 2x plus 4 going to equal negative 3x minus 1? So you would add 3x to get 5x. And then you would also subtract the 4. So 5x equals negative 5. So at negative 1, they should cross. Well, we might as well see if that's actually true. Remember, this is a slope of 2, so negative 1 would give 2. And this is a slope of negative 3, so negative 1 would give 2. So this is great. This point is where these two are equal. That's a really important point. Maybe you could have just found that on the table, not even setting them equal to each other if you just go a little farther in both directions. So we're just going to plot these two things. So negative 1, 2, 0, 4, 1, 6. And then that is a dotted line, and it reads is greater than. So we're going to shade above. And then the second one is this table in green. So negative 1, 2, that's where they cross. 0, negative 1, 1, negative 4, and 2, negative 7. Dotted or solid? It's solid because it's greater than or equal to. Solid line. And then greater than or equal to is shaded this way. So the double shading is right here. It goes from this line to this point, and then it's dotted right here, and it's everything up here. So all ordered pairs in this double shaded region or on this solid line are a solution. So you could list solutions, you could just look at that graph in awe and beauty and sit back and smile, and you can feel hopefully very good about graphing systems of inequalities. Have a blessed night.